I'm going to talk a bit about the teenage brain. This is a subject that I've been working on for about the last 16 years. I've been running a group at UCL, and we research the teenage brain. And thank you. And actually, it's interesting because I have very rarely do I give talks with notes. I normally just have loads of science slides behind me, which I talk about. But because this is a book talk, I thought it would be better to kind of mix up a few slides with more of a description, which is a sort of representation of what's in my book. So yeah, the last 3 years in my so-called spare time, I've been writing about the research that we do on the teenage brain. And I'd like to start this talk with this nice letter, which was written by a reader who wrote to the Guardian newspaper. So this is Dina Hall, a reader of the Guardian newspaper, who says, "There's nothing like teenage diaries for putting momentous historical events in perspective. This is my entry for the 20th of July, 1969. I went to Art Centre by myself in yellow cords and blouse. Ian was there, but he didn't speak to me. Got a poem put in my handbag from someone who's apparently got a crush on me. It's Nicholas, I think. Man landed on moon." This is a really nice illustration because it shows us what's important to that particular teenage girl at that particular moment in her life. Less important is the fact that man happened to land on the moon for the very first time that day. And more important are things like what she's wearing, who she likes, who she doesn't like, who she's hanging out with. Adolescence is the period of life in which we develop our sense of self-identity, and particularly our sense of social self. That is how other people see us. That, I think, is what adolescence, this period of life that I'm talking about today, is all about. It's developing a sense of who you are, and particularly how other people see you, so how you're seen in your local community. That is what adolescence is about. It's about constructing ourselves. So as John said, we as a society appear to think that it's completely acceptable to mock this age group. Like John said, whenever I tweet about working on the adolescent brain, invariably I will get a tweet back saying something like, "Well, that's not going to take very long, is it?" Implying I think that there's no brain to find, or it's very small. I'm not quite sure what that implies, but I'll always get some kind of jokey reply about teenagers. It's a really interesting phenomenon that we, as a society, allow ourselves to laugh at this age group in a way. And there are whole funny comedy shows on exactly that subject, mocking teenagers. And it's interesting because we don't really find it socially acceptable to do that with any other sector of society. Something about our view of this age group allows us or makes it socially acceptable to make fun of them and also to demonize them a bit. They have a very kind of bad reputation. We are very quick to blame them and to sort of blame their behavior, which I'm going to talk about a lot today, on their own decisions and their own decision to be moody and impulsive and risk-taking and particularly influenced by their peers and lazy, not getting up in the mornings, that kind of thing. But actually, adolescence is a really fascinating period of life, and it's a really important period of life in which we all have to go through to become independent adults. Adolescence is really fundamental to the adult we become. Okay, so I'm now going to ask you to get out your mobile phones, and instead of turning them off, I'm going to ask you to log on to the Wi-Fi. So if you get out your mobile phones, and then once you've logged on, once you've got good Wi-Fi or good 3G or 4G, log on to menti.com. Ross, can you show the first Menti question? So now what you have to do is answer this question: what age do you think adolescence stops? So when does this period of life end? And you've got a multiple choice of 5 answers there. So if you all just put in what you think, and there's no, I'm not going to tell you the answer now. It's just interesting to see what everyone thinks the answer is to this. Brilliant. Okay, so 194 of you have entered some answer. We'll just give it another few seconds. Okay, we should probably move on. So can we look at the results? So there's quite a spread of responses, and most people are saying age 25. Interesting that some people are saying never. Okay. Well, I'm going to talk about that now, actually. So, what is adolescence? What's the definition of adolescence? I'm always asked this, and it's an obvious question. There's no simple answer. Some people think of adolescence as the teenage years, as synonymous with the teenage years, say 13 to 19. The World Health Organization defines adolescence as the second decade of life, so 10 to 20. Stanley Hall, who was the first person to coin the term adolescence to describe this age group about 100 and odd years ago in the US, described it as the period of life between puberty, so around age 12 to 13 back then, up until about age 25. The definition of adolescence that I use and lots of my colleagues use is the age between puberty, so it starts with the physical and biological changes at puberty. And the end of adolescence, in the way we define it, has a much more fuzzy and vague definition, which is the age at which you attain a stable, independent role in society. That's the never people. So that can go on a long time. And the interesting thing, if you think about it, about that definition, is how different adolescence, this concept of adolescence, is between cultures. So in our culture, it's completely normal and socially acceptable for young people to be not independent, so to live at home with their parents in full-time education throughout their teens, of course, and even beyond that into their 20s or even their 30s. Whereas in other cultures around the world, that's not the case at all. And young people, children, are expected to become independent, like earn their own money and as soon as they can, and have babies as soon as they reach sexual maturity. So the concept of adolescence and the way and social expectations of adolescence differ vastly between cultures. And some people have argued, because of those cultural differences of the whole concept of adolescence, that this concept is a recent invention, coined, yes, by Stanley Hall about 110 years ago in America. So something that's new, that's invented recently. But actually, I think there are some really good reasons why that's not the case, and why, in fact, adolescence is a really important period of biological and psychological and social development. Before I tell you about those reasons, I'm going to ask you to answer a couple more questions. So can we have the next question? So get your phones back out. Menti, it will go, if you just refresh the page, you'll get the next question. So at what age do you think the human brain stops developing? Okay, so can we show the results? That's interesting. So most people are saying never, and some people are saying 24, and some 30. Okay, I'll come back to that later. One more question. If you go, press refresh. Okay, this is a tricky question. The question is, how many neurons does a newborn baby's brain contain? But I'm going to give you a clue. So the clue is that an adult human brain, so most people in this room, an adult human brain contains around 86 billion neurons. So knowing that, how many neurons does a newborn human baby's brain contain? Okay, can we show the results? So most people think a newborn brain contains 240 billion, and some people 86 billion. Okay, I will come back to those later on in the talk. Can you go back to my slides now, please, Ross? Thanks. Okay, so I mentioned that there are these big cultural differences in the way we think about adolescence, but nevertheless, it seems that certain adolescent typical behaviors, by which I mean behaviors that we stereotypically associate with this age group, so behaviors like increased risk-taking or impulsivity, peer influence, heightened self-consciousness, behaviors that we tend to think of when you hear the word teenager or adolescent. You can see those behaviors across cultures, even in cultures where societal expectations of this age group vastly differ. So there was one experiment, there are actually very few experimental research studies looking at that. It's really hard to do, as you can imagine. But there was one study published a couple of years ago, actually probably published about 1.5 years ago, by Larry Steinberg and his colleagues. They studied different behaviors across 11 different cultures. And these cultures are very different in terms of how young people are treated and the expectations placed on those young people. Nevertheless, they showed pretty similar developmental trajectories of two particular behaviors. One is sensation seeking. Sensation seeking is defined as the desire to seek novelty and to take risks. And across those 11 different cultures, although there were some subtle differences, most of those cultures showed a very similar developmental pattern for sensation seeking, which is this. So this, what you can see here is sensation seeking plotted on this axis here, the vertical axis, plotted against age from 10 to 30. So sensation seeking increases during the teenage years. It's highest in the late teens, which is what that bar corresponds to here. And then it decreases again during the 20s. So across cultures, there seems to be a peak in sensation seeking and risk taking in the late teens. And then that declines again. Whereas self-regulation, which is the ability to regulate and plan your behavior and inhibit risk-taking, stopping yourself taking risks, has a different developmental pattern, which is really similar across these 11 different cultures. So across those cultures, self-regulation improves gradually during the teenage years, and it levels off into the 20s. So teenage typical behavior like sensation seeking and also the ability to regulate your impulses and your actions appear to be pretty invariant across cultures, also across species. So interestingly, adolescence is not specific to humans. It's not just humans who undergo this period of life. All animals go through a period of life between puberty and becoming fully sexually mature adults. And in that period of their lives, you can measure their behavior, and lots of scientists do this all around the world, particularly with mice and rats. Mice and rats go through about 30 days of adolescence between going through puberty and becoming fully sexually mature adults. And in those 30 days, you can see increases in things like risk-taking and exploration of their environments and changes in the way they behave socially and their social behavior. There was one study published a few years ago showing that adolescent mice drink more alcohol when they're with other mice, but that's not the case for adult mice. So this graph shows that result. So here's the amount of time that the mice spend drinking alcohol when they're on their own here. This is the blue bar is the adolescent mice and the red bar is the adult mice. So they drink around the same amount when they're on their own, but when they're with their cage mates, adolescent mice drink lots more than they did when they're on their own, whereas adult mice drink around the same. So adolescent typical behavior isn't restricted to humans, but you can also see it in other species as well. There's a nice quote, so I dig out quotes, I look for and keep quotes about adolescence from various newspapers. Again, this is from The Guardian. I don't know if you remember, you probably don't, but about 3 years ago, 2 or 3 years ago, a woman in Australia was attacked by an adolescent wombat. It didn't really make front page news, but it did make the newspapers, or at least The Guardian. And The Guardian had a quote from a guy called Martin Lind, who was from the Australian Wildlife Service. And I'm not going to do this in an Australian accent, but you can imagine it in an Australian accent. He's talking about adolescent wombats. He says, As babies, they're clingy, they're adorable, they're with mum 24 hours a day, they're in a soft, snuggly sleeping bag all the time, listening to a heartbeat. When they start to mature and hit puberty, they just hate everybody and everything. They go from running between your legs and cute as a button to being absolute little, can I swear, little shits. They nip you, they wreck, they bite. I won't look after adolescent wombats because you kiss goodbye to your flooring and everything. They just destroy everything. I thought that's really nice because it could equally be written about adolescent humans. Okay, history. The third reason why I think we shouldn't think of adolescence as some kind of recent Western phenomenon is because if you read descriptions of this age group throughout history, there are many, you see striking similarities with the way we describe this age group today. So in this kind of stereotypical, slightly mocking, slightly denigrating way. Here, I'm going to read you a few quotes. So this is Socrates, almost 2,500 years ago, talking about youth. He says, "The children now love luxury. They have bad manners, contempt for authority. They show disrespect for elders and love chatter in the place of exercise." All these people are really quite irritated with adolescence for some reason. This is Aristotle, who says, "The young are in character prone to desire and ready to carry out any meaningful desire they may have formed into action. They're changeful too and fickle in their desires, which are as transitory as they are vehement, for their wishes are keen without being permanent. They are passionate, irascible, and apt to be carried away by their impulses. Youth is the age when most people are devoted to their friends, or when people are most devoted to their friends or relations or companions, as they are then extremely fond of social intercourse and have not yet learnt to judge their friends or indeed anything else by the rule of expediency. If the young commit a fault, it's always on the side of excess and exaggeration, for they carry everything too far, whether it be their love or hatred or anything else." I mean, that's 2,500 years ago by Aristotle. Very similar stereotypes to the way we sort of stereotype this age group today. Shakespeare, about 400 years ago, in The Winter's Tale says, "I would there were no age between 10 and 3 and 20, or that youth would sleep out the rest, for there is nothing in the between but getting wenches with child, wronging the ancientry, stealing, fighting." Rousseau, about a century after Shakespeare, says, he's describing adolescence, he says, "A change in humour, frequent anger, a mind in constant agitation makes the child almost unmanageable. His feverishness turns him into a lion. He disregards his guide. He no longer wishes to be governed." So for millennia then, adolescents have been painted in the same stereotypical terms as we often use them today. This certainly suggests that adolescence is not some kind of recent Western phenomenon. So when did I become interested in adolescence? John mentioned my PhD. I did my PhD here in London a long time ago on schizophrenia, which, as you may know, is a really devastating psychiatric condition that's characterized by symptoms like hearing voices, auditory hallucinations, hearing voices inside your head, and delusions of persecution or paranoia, so thinking that other people are out to get you and you're being followed by MI5 or other people trying to harm you in some way. I also did postdoctoral research on schizophrenia in France, and what I noticed after testing or during testing many hundreds of patients in hospitals, both in the UK and also in France, is that every time I asked a patient, "What age did you start experiencing these symptoms?" without a single exception, they all said at some age between 18 and around 26. So I became interested in why this was. What is it about teenage brain development that is different in teenagers who go on to develop schizophrenia? At that time, that was around the year 2001, very little was known about how the human brain develops. Virtually nothing was known about how the human teenage brain develops. So it was around then that I decided to change the focus of my own research and to start studying the adolescent brain. And I have to say and acknowledge at this point the support of one of my mentors, Professor Uta Frith, who she had been a mentor to me for many years. I had been supervised by Chris Frith, who is her husband, and I couldn't make it, unfortunately, but some of you may have seen their joint talk here about 6 months ago. So I was supervised by Chris, but Uta was very much one of my mentors, and she encouraged me to take this risk because it really was a risk, switching fields from working with patients with psychosis to working on the developing brain, because I had never before done a developmental study. But with Uta's encouragement, I changed the focus of my own research and have been doing that ever since. Okay, so I asked you when you think the brain stops developing and how many neurons you think there are in a newborn baby brain. And I did that for a reason, because when I started to become interested in this area, like I said, and up until that point, I had always been taught that the human brain mostly develops in very early childhood and stops developing at some point in mid-childhood. That's what I had learned during my undergraduate degree. I know that because I kept my undergraduate textbooks, and I still have them, and they say things like that. They talk about how human brain development stops in childhood. And that's because that's completely wrong. And that sort of dogma, that false dogma that we were taught, was simply because actually no one really knew, and they were making an informed guess based on mostly based on animal research and on research with post-mortem human brains. But since around the mid-90s, scientists all around the world have been able to scan the living human brain of all ages using MRI scanning. So some of you may have had an MRI scan, either for clinical reasons or for research. That's what it looks like. You lie inside a tube of an MRI scanner, and that kind of scanner can be used to scan your body or your brain. In research, in neuroscience, we're really interested in using MRI to, for example, tell us about the structure of the human brain. That's what you can see here, and we measure, using these structural MRI images, we measure things like the volume of grey matter and the volume of white matter. So if I just take my brain here, mostly grey matter is found in the surface of the brain, in the cortex, which is just underneath the skull, and grey matter contains neuronal cell bodies and connections between cells, synapses, amongst other things. And we also measure white matter, which is mostly found in the center of the brain. And white matter contains the long fibers along which electrical impulses pass from neuron to neuron. And they're called axons. Those axons allow neurons and brain regions to communicate with each other. So we are able with MRI to measure the amount of grey matter and white matter the human brain contains and look at how that changes across the lifespan. We also use MRI to scan the brain while it's active, so while you're doing a particular task, and we could look at brain activity and how that changes across the lifespan. So what have those MRI studies taught us about the developing brain? The answer is a huge amount. So if we focus on the structural studies and the amount of grey matter and white matter the brain contains, so first of all, white matter, we know from many, many studies, but including one that's been done recently by many people, including Kate Mills. Kate was a PhD student here with me at UCL. She's now an assistant professor at Oregon, the University of Oregon, and Christian Tamnes, who is at the University of Oslo, amongst many other people, looked at MRI scans from many different people, many different children and adolescents in 4 different places. So at NIH and Pittsburgh, which are both in the USA, in Leiden in the Netherlands, and Oslo in Norway. So in total, 391 participants, children, adolescents, young adults, were scanned, and each one was scanned every couple of years as they got older. So this is a longitudinal study of brain development. And altogether, we were analysing 852 MRI scans from different people. So what you can see, first of all, is that the amount of white matter in the brain increases across childhood and adolescence. So this is the amount of white matter in the brain, plotted against age from 5 to 30. And that in all of the 4 different cohorts, so that's what these words correspond to here, the 4 different cohorts, so NIH and Pittsburgh and Leiden and Oslo, all of them showed a significant linear increase in white matter. White matter increases about 1% per year throughout the whole of adolescence. So the brain is increasing the amount of white matter it contains. But interestingly, it's not getting bigger. The brain does not get bigger from about age 8 or 9. From about age 8 or 9, the human brain is pretty much adult size. So the brain doesn't grow, but the amount of white matter it contains increases. And at the same time, the amount of grey matter decreases. Perhaps not surprisingly, the whole brain isn't growing, so something has to decrease, and that's grey matter. And that's what you can see here. So this is grey matter across the cortex, so the surface of the brain, the whole of the surface of the brain, averaged. Again, in the 4 different cohorts, showing a very similar pattern of grey matter being highest in late childhood and then decreasing during adolescence and plateauing off into the 20s. The brain loses about 1.5% of its grey matter each year during the period of adolescence. So it's a really substantial decrease in grey matter. Now, that might sound bad. It might sound like neural degeneration or decline, but actually we don't think this decline in grey matter represents any kind of degeneration. Partly because it then plateaus off and stabilizes for many, many decades and doesn't change after that. But also because of what we think is going on at a cellular level to underlie this decrease in grey matter. So that's what I'm going to talk about now. Why does grey matter decrease and white matter increase during adolescence? Well, the first thing to say is that we don't actually know, because MRI scans, although they give us these beautiful pictures of the human brain, they don't show us the brain at the level of the cells or the synapses. For that, we have to go to animal studies and to studies of post-mortem human brain tissue, which we can look at slices of under a microscope. And from those studies, we know that during adolescence, 3 really important neurodevelopmental processes are happening. The first is myelination, which is where the axons, those fibers along which electrical impulses travel, become coated in a substance called myelin. It's a fatty substance, and it appears white under the microscope. And that is what white matter corresponds to when we see it in MRI scans. So myelination, the axons are being coated in myelin, which, by the way, enables the signal transmission to be speedier. It speeds up signal transmission along the axon. And we know that that's happening during the period of adolescence, which is probably why you see this increase in white matter in the brain. Also, axons are growing, so those fibers are growing in diameter, and that will also speed up the signal of the transmission speed of the signals along the axon, and it will also result in an increase in white matter during adolescence, as seen in MRI. And at the same time, and by the way, if the brain is not growing, then as it becomes more white, it has to have a concomitant decrease in grey matter. So that will account partly for the decrease in grey matter we see. But both of those processes are really important neurodevelopmental mechanisms. And a third neurodevelopmental mechanism that's happening in adolescence is synaptic pruning, whereby synapses that are being used in a particular environment remain and are strengthened, and synapses that are not being used in that particular environment are the ones that get pruned away and eliminated. And in that way, the environment plays a role in shaping the development of the brain during the period of adolescence. And all these 3 processes can lead to increased neuroplasticity during adolescence. So the way the brain adapts to its environment and changes according to environmental stimuli. Okay, so just to go back to those questions that I asked you about the brain. So when does the human brain stop developing? Well, in some ways, it's a trick question. It's a question I'm asked all the time, by the way, in the context of things like ages of consent, age of criminal responsibility, legal implications when young people should be able to vote, that kind of thing. And actually, it's not really a question that makes much sense because, firstly, we don't really know what a adult brain looks like. I mean, maybe we will one day, but at the moment we don't have a kind of clear idea of what a scan of an adult brain versus a child brain would look like. Certainly not on a single scan, single subject level. Also, there's a sort of age range. Different brain regions develop at different rates. There are huge individual differences, so different people's brains develop at different rates. And finally, in some ways, and I think lots of you answered, it never stops developing. I think that's right. The brain never really stops changing, at least. These kinds of, I mentioned neuroplasticity. There's no age limit to neuroplasticity. Whenever you learn anything new, something, probably a few thousand synapses in your brain have changed. They've grown stronger. And there's no age limit to that. You can learn new things at any age because of neuroplasticity. The third question I asked you about how many neurons does a newborn baby brain contain? Okay, so the answer was exactly the same as an adult brain, 86 billion. And it's a kind of trick question, and it's a bit mean, because a lot of you answered, I think, 240 billion or whatever, the figure that was higher than the number of neurons in the adult brain. But actually, the number of neurons, the number of cells, which is what you can see here, the diagram of, in the brain, doesn't change very much at all. There's some neurogenesis, there's some generation of new neurons, not very much, and there's some neuronal death, again, not much. The change, the number of neurons remains pretty stable throughout life, from birth all the way into old age. What changes is the number of synapses. And you are right that the number of synapses is hugely greater in childhood. The brain massively overproduces synapses in childhood. And then it has to get rid of those synapses, and that is where synaptic pruning comes in. So when I was a teenager, most teenage typical behaviors, which I've talked about a lot, were put down to changing hormones and sort of social changes, like changing schools. But actually, now we know that the brain changes hugely as well. These changes in the brain are at least part of the jigsaw puzzle in trying to understand the transition of adolescent and adolescent typical behavior. So what are some of these behaviors? Well, one is embarrassment. Embarrassment is something that really seems to kick in adolescence, particularly embarrassment in front of your parents. One of my friends said to me that the main difference that he noticed in his children, his two daughters, before and after puberty, was in their levels of embarrassment, particularly in front of him. So before puberty, if they were messing around in a shop, say, he would say, "Stop messing around and I'll sing your favorite song." And they would instantly be quiet and he'd sing to them. And after puberty, that became the threat. The idea of their dad singing in public was enough to make them behave. There are so many examples of adolescent embarrassment. I have a friend who recently bought a pair of blue trainers, and his 14-year-old son immediately said, "Did you choose them off the midlife crisis shelf?" And he's banned from wearing those trainers in the entire village in which his two teenage sons go to school. And they make him keep a spare pair of shoes in the car just in case he forgets that rule. Even my own children, so I'm a governor at my children's school, the primary and the secondary school, both of them. And the difference between my 10-year-old and my 13-year-old's reaction to this is just startling. So we had a recent visit of the governors to the schools. My 10-year-old was like, "Can I organise your visit? Can I show you around? I'm going to ask my teacher if I can show you around." My 13-year-old said, looking really horrified, "Oh my God, do you mind if I pretend not to know who you are?" So why is this? Well, there was a study carried out by Leah Somerville at Harvard a few years ago, where she put people in an MRI scanner and she recorded brain activity while she told them that they were being observed. So she said, occasionally when you're lying in this tiny tube, a red light will come on in front of you, and that indicates that you're being observed by two people your own age in the scanning control room. In fact, this was just a cover story and they weren't being observed. But what she found was that when the red light came on, when people thought they were being observed, that led to increases in the self-rated level of embarrassment in the adolescents compared with children and adults. Also, the amount of sweat the skin produces, which is a measure of stress, was highest in the adolescents, higher than in children or adults. And part of the social brain, called the medial prefrontal cortex, which is right at the front in the middle of the brain, its activity was higher in adolescents than in adults. So there seems to be something kind of physiological underlying this increased self-consciousness we feel as adolescents. Okay, I'm going to talk about risk-taking, which is another adolescent typical behavior. We worry about teenagers taking risks. And actually, I mean, there are so many examples of this, but one example that I experienced recently, a couple of summers ago, I was driving home and I was on an A road, very fast, very dark A road, in the middle of the night, driving home from Oxford to my house in Hertfordshire. And I noticed a girl walking along this road. I mean, pitch black road, cars going at 60 miles an hour, occasional cars. So I stopped and said, well, do you want a lift home? Where are you going? She got in the car. She's like, oh, yes, please, that would be nice. And turned out she'd been in a pub. She was about 18. She'd been in a pub. She was having a great time with her friends. She'd spent her taxi money on beer. She had let her phone run out of battery because she was filming her friends put on Facebook or whatever. Probably not Facebook, actually. That's really uncool with young people. Instagram or whatever. Obviously, the buses had stopped by then, so she was going to walk home. I was like, oh, right, how far is your home? 8 miles away. So she was planning to walk 8 miles in the middle of the night. And I thought, that's the kind of thing I probably would have done when I was 18, but I wouldn't dream of doing it now. There is something about adolescence which does make us, as adolescents, when we're adolescents, more susceptible to taking risks. But what I think is really important is the idea that it's not just as simple as that. Not all adolescents take risks. Lots of adults take risks. Lots of risks are really beneficial. We learn by trial and error, and risks can benefit us. And also the context of risk-taking, particularly the social context, like the girl I picked up, the young woman I picked up, it was all about being out with her friends. That's why she was willing to take the risk of abandoning all her safe ways of getting home, because she was having fun with her friends. So in the kind of heat of the moment, particularly when with friends, I think that's when adolescents are most likely to take risks. Okay, I've now got a demonstration of a little experiment, a risk-taking experiment. So this is a balloon. It's called the BART task, which is the balloon analog risk-taking task. It's a very weird task, but it's very interesting, and I'll tell you about it afterwards. So I need some volunteers. I need 8 volunteers, preferably of different ages, but it doesn't really matter if not. Any? Okay, you come down, you come here. It's quite hard for me to see. Yeah, sure. And you, you too, yeah, great. We need a mixture of genders. You want to? Yeah. Okay, we've got 1, 2, 3, 4, 5, 6. 2 more. You. 1 more. You. Okay, so what I want you to do, now, there's a prize in this. What I want you to do is blow up these balloons as much as you can, as big as you can. And the 2 people whose balloons have the biggest circumference will win a signed copy of my book. I don't know whether that's really a prize or not, but anyway, I've got them here. And if Jack and Javita, if you can come down, because they're gonna measure with these very scientific instruments. They're not scientific at all, and they're also different, which is probably a problem. But anyway, the circumference of these balloons, and they're also going to take your name. So, and be careful, because the balloons can pop. So you want to blow up the balloon, and when you think you've got it as big as you can without it popping, try and tie a knot in it and give it to one of my assistants. Jack Andrews is doing a PhD with me, and Javita Lung is about to do a PhD with me. She's my research assistant. Okay, so I think you're out. So yeah, if you measure the balloons. You can do some estimation. This is not a real experiment. There's a digital version of this task that you can do on a computer. And interestingly, okay, so the finding is that adolescents take more risks on this kind of task, where they're incentivized, like they're going to win a reward. Okay. Well, that's a good example of what I was just about to say. So if they're going to win a reward, they take more risks. In other words, their balloons blow up more than adults' balloons do, because they want to win and they want to take the risk of. And it's interestingly, because it's such a weird task. If you do it online, it's obviously much more controlled than this. But it's a weird task, but it's the level of risk-taking that you show on this task is correlated with real-life risk-taking, like experimenting with drugs or cigarettes or alcohol, which is really interesting. This is not a scientific version of this task, so we don't have to read anything into this with these results. So who won?
So Zarina got 73 centimetres.
You, Zarina.
And Kat got 72.
Who? These two. So I mentioned that the key factor in risk-taking in adolescence seems to be social influence. There's something about being with friends that make adolescents more susceptible to taking risks. And that was shown really nicely in an experiment that was carried out by Larry Steinberg and their colleagues a few years ago, where they asked participants to carry out this driving video game where you drive around a circuit as quickly as possible, and he measures the number of risks you take. And he studied various different age groups, and what you can see here is the number of risks taken by adolescents. These are age 13 to 16 here, in this leftmost graph bar. Young adults aged 17 to 24, and adults aged 25 and over. And what you can see is actually when they're on their own, when they can focus on the task at hand, there's very little difference in the number of risks adolescents and adults take. So this stereotype that adolescents always take risks is just the stereotype. It's not always true. However, in a second condition, the researchers asked the participants to bring a couple of friends with them, and those friends just stood behind the participants as they carried out exactly the same driving task. And that resulted in 3 times the number of risks taken by the 13 to 16-year-olds and twice the number of risks taken by the 17 to 24-year-olds, and it had no effect on risk-taking in adults. So what this shows is that peer influence is the really critical factor in risk-taking. These kinds of data are very much borne out by real-life data from car insurance companies. So car insurance companies, as you may know, when you make a claim after an accident, you have to fill in a lot of information about the precise circumstances in which the accident took place. And that data is quantified and analysed. And what it shows is that young people under the age of 26 have more accidents than older people. That's why their premiums are higher. But also it shows that the precise circumstances in which young people are most likely to have accidents is when they have similar-aged passengers in the car with them. And that's not the case for adults, for whom having a passenger in the car is protective. You're less likely to have an accident if you have a passenger if you're over the age of 26. And there are now policy implications. There are countries that have brought in legislation which doesn't allow young people to carry non-family related passengers in the car with them for a couple of years after they've passed their test, and car insurance companies are also doing the same kind of thing. So why is it that adolescents are particularly susceptible to peer influence? Well, one possibility that we have been looking into is that adolescents might be hypersensitive to being excluded by their peer group. They might be really worried about being ostracized by their peer group. And we did an experiment a few years ago looking at the effect of social exclusion in adolescence. And this was an experiment using cyberball, which is this kind of online ball throwing game. So you're told that this is you down here, and you're going to be playing a game of catch over the internet with these two other players. In fact, that's just a cover story. There are no other players, and we program those other two players either to include you in the game of catch or to exclude you. And we did this experiment many years ago when people were like, wow, that's so cool that you can play a game of catch with people over the internet. Now I don't think anyone would believe that this is a real game because you can do something so much more sophisticated on your own phone. Okay, this is what an exclusion condition looks like. So you get thrown the ball, you can decide who to throw it back to, and they could throw it back to you, these other players, but in this case they don't. They just continue playing with each other for about 2 minutes, and that makes you feel really sad. That decreases mood and increases anxiety in adults. So with Kat Sebastian, who was my PhD student many years ago, she now runs her own lab at Royal Holloway, we wondered what would happen to adolescents if they took part in this task, and I'm going to go through the results. So these are the results in the adult group. This is their mood as measured by a standardized mood questionnaire. At baseline, so that's the yellow, before they'd taken part in the experiment, after being included in that game of catch, that's shown in green, and then after being excluded, that's their mood in blue. So the adults that took part in our experiment showed a significant decline in mood after being socially excluded, which is what other people had already found. And the adolescent group, so we tested a group of 11 to 14-year-olds here, and a group of 14 to 16-year-olds, they both showed the same pattern of results as the adults, but their drop in mood was significantly greater than the adults. So what this suggests is that adolescents are hypersensitive to being socially excluded. So what does this mean for adolescent behaviour? Well, if you think about this hypersensitivity to social exclusion and the need to avoid being socially excluded, to avoid what you might call taking a social risk, it sheds adolescent typical behavior in a more rational light. So one of the questions I'm often asked by teachers or parents is why a perfectly kind of intelligent and educated young person might make a decision like try a cigarette when they know all about the health risks of smoking. But if you think about the situation in which most young people take that kind of risk, it's when they're with their friends. So if you imagine a 13-year-old who is out with her friends at the weekend and they offer her a cigarette, what for her is the more risky decision, saying yes to a cigarette when she knows all about the health risks of smoking, or saying no and potentially being ostracized by her peer group? Well, we would argue that social risk weighs in much more heavily for young people because they're driven to affiliate with their peer group and to be included by their peer group. Now, that's not to say that it's a good idea, but it sheds those kinds of adolescent typical behaviors in a more rational light. But I wanted to end by showing that we're all influenced by other people. So if you can get back onto your phones and again, go to menti.com, and Ross, if you could go to the 4th question. Okay, so without any discussion, this is really hard, just have a think about what the circumference of the London Eye is. Okay, I think we're going to move on. So Ross, don't show the results yet. If you just go on to the next question. Now, in small groups, so in groups of like 4 or 3 or 4 or 5, just next to you, it's exactly the same question. Discuss for 45 seconds only how the circumference of the London Eye. Okay, now you need to vote again. Stop talking and vote again. So each of you should vote again. And you're not allowed to Google it, obviously. Okay? Everyone needs to vote again. Each individual person needs to vote again. They'll add up to about 200, because I think that was the last one. Okay, so Ross, if you could go back to the previous question and show the results from that. All over the place. Okay, I can tell you that the true answer is 424, which actually I think got the least number of votes. And okay, so that was when you were not discussing. I have no idea whether this is going to work, by the way. Ross, can you show the results of the next question? It got a bit better. Anyway, the main point here is to show it doesn't matter about the actual results, but to show how we are influenced by other people. We are all influenced by others. Everything we do, if we do it when we're with other people, is slightly different compared with when we do it on our own. Our behaviour is changed when we're in groups, when we're in crowds. Our cognitive performance, for example, is different if we're being observed by someone else compared with when we're not being observed. And you perhaps experienced that just now. Just discussing things with other people makes you think differently about questions and about decisions. So I'm going to end there just to say that Stanley Hall, when he first described this period that he called adolescence, described it in a very kind of rich, broad way. He talked about things like indifference, lethargy and melancholy, energy and exuberance. He talked about adolescence reflecting a combination of uninhibited childish selfishness and an increasing idealism and virtue. And although many of his stereotypes have just been dismissed as caricatures, he was right, I think, to highlight the importance of friendships and peer influence in adolescence, as well as the urge to explore the world with curiosity and energy and to experience novelty. These are characteristics that are the focus of much of today's research on the adolescent brain. To end, I want to say that the adolescent brain isn't broken. We shouldn't think of it as a kind of dysfunctional or defective adult brain. It's a formative period of life when the brain is changing in really important ways, and we shouldn't demonize it. We should understand it and nurture it and support adolescence and celebrate adolescence. When a few years ago I had an amazing opportunity to work with what was then called the Islington Community Theatre. They're now called Company 3, a very big group of young people. It's a youth theatre company in Islington. And they were writing and performing a play called Brainstorm, which was their interpretation of the science of the teenage brain. And this had ended up having 2 runs at the National Theatre to critical acclaim. And we're very lucky to have one of the stars of Brainstorm here, Yamin Chowdhury. And I'm going to sit down while he gives his main soliloquy from Brainstorm.
You say to me, your brain is broken. It's like an adult's brain, but it doesn't work properly. You say, when you become a teenager, something happens. Your brain shrinks or something. It stops working properly. It gets so full of thinking about yourself that you forget about anyone else. It's like you're in a city you've never been to, and you don't have a map, and you don't know what you're doing, and you keep taking the wrong turns. You say, listen to me, don't worry. One day you'll be okay, probably. Your brain will start working properly. One day your brain will be just like mine, and then you'll be okay. But until then, you've got to try and be more like me. I say to you, my brain isn't broken, it's beautiful. I'm in a city I've never been to, and I see bright lights and new ideas and fear and opportunity and 1,000 million roads all lit up and flashing. There are so many places to explore, but you've forgotten that they exist because every day you walk the same way with your hands in your pockets and your eyes on the floor. I say, my brain isn't broken. It's like this for a reason. I'm becoming who I am. And I'm scared. And you're scared because who I become might not be who you want me to be or who you are. And I don't know why, but I don't say, it's all going to be okay. There are so many things I stop saying to you. I want to say them, but I don't. I pick up my plate, put it in the kitchen, and go upstairs. Thank you.